Hello, my name is Rohan Dhawan. In this video, I'll walk you through my project, FactoryGuard AI, which is an end-to-end predictive maintenance system built for industrial machine failure prediction. I'll explain the problem statement, the week-wise implementation, and finally how the model is deployed as a service with explainability. So, in large manufacturing plants, unplanned machine failures can cost thousands of dollars per hour due to downtime. The goal of this project is to predict machine failure in advance using sensor data like vibration, as mentioned in this dataset, vibration, temperature, and current, so that the maintenance can be scheduled proactively instead of reactively. This project follows a complete production machine learning life cycle and is implemented in 4 stages: data engineering, modeling, explainability, and deployment. So for the week 1 task, in week 1 the focus was on converting raw sensor logs into a clean model ready dataset. As mentioned in this code, I handle missing sensor values using machine-wise interpolation, which is appropriate for continuous time series data. I then created lag features like T1 and T2 to capture historical behavior, and rolling window statistics to capture degradation trends over time. Most importantly, I ensure no data leakage, meaning the model never sees future information while predicting the past. For the week 2, the goal was to build a strong predictive model while handling the challenge of rare failure and events. I started with a random forest uh, baseline and then trade an XGBoost model which is well suited for non-linear patterns in sensor data. Since failures are rare, I focused on recall and F1 score rather than accuracy, because missing a failure is far more costly than a false alarm. And hyperparameters were optimized using randomized search CV. And I can also show the execution of this code. As you can see, random 4 results are mentioned: recall value, F1 score, precision recall F1 scores, purport, and XGBoost results are also mentioned: recall, F1 score, etc. In industrial environments, model predictions must be interpretable, not black boxes. So in week 3, I use Shapley additive explanations to understand why the model predicts a failure. I generated global explanations using SHAP summary plots to see which failures generally drive failures. I also generated local explanations using SHAP force plots for individual machines, showing exactly which sensor readings increase the failure risk. This helped validate that the model's behavior matches physical expectations such as higher temperature and vibration, increasing failure risk. Let me just show you by executing this code. So as you can see, this is the shape of our model, train shape and test shape of our dataset. This is the shape summary plot. These are the values for various sensors: temperature, vibration, current, temperature roll mean, acoustic, vibration roll mean, etc., etc. And these are the results. This is the shape force plot, and this is the shape summary plot. Let me open it. This is a shape summary plot, and this is our shape force plot. Vibration roll mean value, temperature roll mean value, everything is mentioned in it. Current, acoustic, everything is mentioned in it. For the final stage, that is our week 4 task, deployment. In week 4, the goal was to make the model usable in real world operations. I serialized the train model using joblib module and deployed it using a Flask REST API. The API accepts new sensor data. The API accepts new sensor readings in JSON formats, and returns two things: the failure probability and a share-based explanation showing the top risk factors. This ensures that every prediction is both actionable and explainable. Since this was demonstrated, now let me show you the actual result. Let me execute this first. So let us execute our API. So our code has run successfully. Now let's open our API, which is on the server. Let's follow this link. So this is our FactoryGuard AI predictive maintenance system. This is just for the demonstration purpose, that's why I'm putting any value. Now let's predict failure risk. So as you can see, failure probability is very minimal here, with a percentage of 0.46. Sorry, actually safe. I'm wrong. Failure risk is high, safe is low. Failure probability is very high, 99.54%, as per our reading, sensor readings as were mentioned over here. Okay, so here are risk level: critical, acoustic reading, increase risk by acoustic sensor, increase risk by 0.7%. These here. So here, FactoryGuard AI demonstrates a complete machine learning lifecycle from raw data to production deployment, with a strong emphasis on explainability and real-world usability. Thank you for watching.